So we are going to do part 8, that is definitely pattern deviation plot, pattern deviation numeric plot, and pattern deviation probability plot. So definitely in single field analysis, let's move. Today we have to discuss about very good interesting thing, that's seventh point. Okay, so what is pattern deviation? It gives the total deviation plot after correcting it for generalized field effect. That's a very good point. We will come later on. If generalized field effect, it means from total deviation plot we remove generalized field defect, which may be due to the region for the generalized field defect, may be cataract, due to vitreous hemorrhage, due to myosis, or maybe refractive correction, uncorrected refractive error, maybe optic atrophy. And then what remains if we actually cut out the generalized field defect? Then what remains is localized field defect, which is localized field defect that is more prominent and which eventually help us for diagnosis of glaucoma, isn't it? The probability plot of pattern deviation that depicts the probability pattern of the deviation being abnormal. Because see, probability plot, as we have already know, depicted by P, and P we have four signs: less than 0.5%, less than 1%, less than 2%, less than 5%, and these signs will depict us actually to the pattern, isn't it? So another thing you must understand, see, numeric data give rise to total deviation numeric plot, isn't it? Raw data actually give rise to total deviation numeric plot by what's the process? By comparing with age normal data, so age match data. So it compare with the normative data. Then uh, total deviation numeric plot, then we calculate the probability pattern deviation numeric plot, isn't it? From total deviation numeric plot, pattern deviation numeric plot is derived. Many of the students did wrong thing. They say that raw data, from raw data pattern deviation numeric plot is there. No, not at all, not at all. It's from total deviation numeric plot. And from total deviation numeric plot, we are definitely eliminating the seventh point. What we are seventh point that we'll definitely discuss. From total deviation numeric plot, we derive pattern deviation numeric plot. Okay, obviously there is, if there is numeric plot, then we will definitely go for probability plot. It's completely okay. So that's the concept. Just don't go this wrong concept. From raw data we derive pattern deviation. That's absolutely wrong. That's wrong. Okay. From total deviation numeric plot we derive pattern deviation numeric plot. Okay. So fine. So that's it. This is the total deviation numeric plot and probability plot. This derivation is pattern deviation numeric plot and probability plot. Okay. So this is the probability. This symbol is same. This symbol is always same. Okay. So no matter what, less than 5%, less than 2%, less than 1%, less than 0.5%. Okay, this is numeric pattern deviation numeric plot. This is pattern deviation probability plot. Okay, so don't panic about it. It's very simple. Okay, and again I'm just emphasizing that pattern deviation numeric plot is derived from total deviation numeric plot, not from raw data, not from this. Okay, again I want to emphasize this thing once more. See, from this raw data we derive total deviation numeric plot. From total deviation numeric plot we derive pattern deviation numeric plot. Okay, from this not at all, not from raw data pattern deviation is not derived. Okay, fine. And definitely when you have that numeric data, then we will can definitely draw probability plot. It's, there is no big science. Okay, so depicted by two plots. So we know pattern deviation numeric plot, pattern deviation probability plot. Pattern deviation plot is created now by pattern and extent of the deeper scotoma and marks by generalized depression of the total deviation. So total deviation probability plot minus generalized depression, this term, is pattern deviation numeric plot or probability plot, whatever. Pattern deviation probability plot never shows the generalized depression. So actually total deviation minus generalized depression is pattern deviation, isn't it? That's why its name is pattern, isn't it? It shows the pattern actually from total deviation, how much totally it deviates from normal, isn't it? Total deviation. Then you remove the generalized depression. What left is pattern, the exact pattern. Okay, so this is a beautiful figure. I always found this figure so fascinating. See, in this picture, don't you think this portion, this uh, let me change the color. This portion is actually generalized depression, isn't it? There's a difference. If you remove this chunk, okay, then you get this. And even in this picture, there is a huge gap. There's a pattern, isn't it? That's a gap. That's you can see here. So that's what we want, because we want a pattern which is hidden beneath the generalized depression. We want the pattern, exact pattern, hidden beneath the generalized depression. Okay. So when the total deviation plot, probability plot, has significant p-value symbols at all points, we can say there is generalized effect. Basically, generalized effect means when a total deviation plot has generally overall depression. Okay, the pattern deviation plot create to known the pattern. That's why its name is pattern. Pattern deviation means from the total deviation we want pattern. Okay, the extent of deeper scotoma. Actually, this is the very important one. The extent of deeper scotoma masked on the generalized depression is called total deviation probability plot. So it means sometimes total deviation plot is like a hill. Okay, and another way to say, and probability sorry, pattern deviation means how irregular that hill is. Actually means how depression, elevation, depression there is. I don't know, I'm making something clear or not. Let it be. So how we convert total deviation numeric plot to pattern deviation numeric plot. Okay, see, this is the main point. The most important key point for the conversion of total deviation numeric plot to pattern deviation numeric plot is to select, this is very great point, seventh best sensitive point to total deviation numeric plot. Okay, and what we will do for that seventh best sensitive point, we'll make that seventh best sensitive point to 0. Okay, so let's take an example. Let's take an example. We have this. Okay, this is maybe 30-2 or 24-2 or 10-2, whatever it is. And just remember, in case of 30-2 and 24-2, there is 3 points that projected on the uh, blind spot. So that 3 points should be eliminated, which means out of 73, here is 76, 73 is left. Out of 54, 51 is left. Now we do what we do, we arrange this point from lowest to the highest. Okay, take this example. This is the point. Actually, what is this? Total deviation numeric plot. Okay, in total deviation numeric plot, now we do what? From lowest to highest, means from, actually don't take minus sign as a very big thing. We always think like a minus sign as a what do you call it? Lowest number, isn't it? The higher the minus is, lowest it is. So what do you do? From numerical value, from minus of smaller minus to the larger minus, we arrange in this fashion, and then we will take first, second, third, fourth, fifth, sixth, seventh position. Seventh position is -5. Then we want what? That seventh position to be 0. This seventh position to be 0. Okay, we want to eliminate that seventh position to be 0. So to make that 0, we want to add +5, isn't it? That's simple. So here's the conversion. This is the seventh point. Okay, all 5 are 7 points. Then you add +5, isn't it? Then what to make? 0 0 0 0 0 0. But see, this -3, what are you gonna do? It's +2, isn't it? So to adjust the generalized height of the vision, the outer state of the point 30-2 are eliminated and shown the figure in the 7th best position, remaining 51 adjacent to 01. Okay, so let it be. We are not concerning with the outer, but the inner, which is 51 position. With 51 means 54 position of 24-2 and 3 points in blind spot. That's why we remove We are concerned with the 51 points. Out of 51, seventh position is -5. So we want to make that -5 0. That's why we add +5. Whenever we add +5 to everything, you get pattern deviation. Everything that is total deviation numeric plot, you get pattern deviation. Okay, that's the case. That's the magic of seventh point. It's very important. So see again in this chart, whenever you go, 7 point is -6. Now see, -6 becomes 0, -7 sorry, -6 becomes 0. Okay, and -5 becomes 1. Okay, so that's how it goes. -7 becomes 1. So that's how it goes, like -6 becomes again 0. So total deviation numeric plot becomes pattern deviation numeric plot. What we are doing, seventh position, we are making it 0. Okay, that's why generalized division. See in this case, this is what we have discussed, isn't it? We add +6 here to make 0, this point, 7 point. But at the same time, can you see here total deviation probability plot? Is there any pattern you can recognize? No. Do you? No, not at all. But can you recognize a pattern? Yes, you recognize this quadrant has darker effect, and this half, what do you call, right hand side, is less defective than left hand side, isn't it? So you can see patterns, isn't it? This quadrant is more defective, isn't it? So from pattern deviation a plot, you can see patterns. It's very important. So is deviation value in the pattern deviation numeric plot give a symbol, and obviously we know do have that symbol. But what do we see here? You cannot see any patterns, but at the same time, whenever we correct seventh position and we derive pattern deviation plot, then you can see patterns. So that's why it's pattern. Okay, so generalized depression in total deviation probability plot and field defect in the pattern deviation probability plot indicates that in case of irregular generalized field defect, you want any irregularity to be shown. Okay, so in case of generalized field defect pattern, deviation probability plots helps to pick up the glaucoma by highlighting the pattern deviation. So if there is a generalized field defect, it's very difficult to say whether there is pattern or not. But whenever we correct that generalized field defect and left only with the patterns, then it's very easy that we can recognize the pattern of the glaucoma field defect. And we have already discussed what are the culprits of generalized field defect. Maybe refractive error, or maybe cataract, maybe miosis, maybe vitreous hemorrhage. There are a lot of things, maybe optic nerve defect. But if we remove that generalized field defect from total deviation, then we will get pattern deviation. In pattern deviation we will get patterns, and that patterns will help us to pick glaucoma early. That's why pattern deviation um, numeric plot is less and less useful whenever we come for the follow-ups. We don't actually, yes, we want to see, but that's not exactly what very important in case of the pattern deviation. Pattern deviation is very important whenever we want to detect the glaucoma. Whenever it's very important, whenever we are first diagnosis, very crucial at that point. Okay, yes, it's definitely crucial for follow-ups, but first diagnosis is very important. Okay, another point, the pattern deviation plot tells us the presence or absence of any localized field defect in a generalized depression. Yes, localized field defect. If present, the pattern and extent of the field defect is revealed. Isn't it? That's what we want, pattern and extent of field defect. This is the reason why the plot is labeled as pattern deviation. Okay, this is the reason. See, here is, you cannot see any pattern, but now see, this field is more defective. It's a pattern, and upper half is less defective. Isn't it a pattern? Yes, definitely there is a pattern. So again, see, this field, you think like total deviation numeric. Oh God, there is something. It's completely devastating, like car crash. But at the same time, can you see it? There is no patterns. So what do you mean by that? What do you mean by that? See, in the last The elimination of generalized field defect and total deviation plus sensitivity at each point is 6 deviation is from this. After removing generalized field defect scotoma is seen probability plot. There is no evidence of glaucoma. So if there is no pattern defect, if there is no defect in the pattern wise, so there is less chances of uh, glaucomatous field defect, because glaucomatous field defect, we know it comes like a pattern, isn't it? So that's why. So I'm big fan of G.R. Reddy's book. That's a great book. I recommend everyone just pick it up and uh, great book. Just remember, just great book. Buy this book. You have to buy this book to your house, to your hostel. I don't care where, and just read this book. Again, this is a great book. Another book, if you want to grow much larger, then this is great book. But for the AV of GRAD's ultimate guide. Okay, so I think I have made my point about pattern deviation. Okay, this done. Cheers.